Hello everyone, welcome to PangeoHub. I am Subham. I passed my masters from BHU. I will be taking your geomorphology classes. So here we are going to discuss the subject from very basic. Those students who have studied a little about geomorphology, it will be very helpful for them. And those who have already studied it, it will be a revision class for them. So here we are going to discuss some basic terminologies and their concept and the mechanism behind their formation, and some mathematical formulas wherever it is necessary. So we are going to start it from very basic. So in this introduction class, we will mainly discuss about the watershed and the concept behind watershed formation, some basic terminologies which are associated with watershed, and how a watershed of a particular area is defined, how it is named, and when we do the practical studies, like due to this corona time we are unable to assess our practical work, so it is very important also to draw the watershed. So I'll give one example of watershed map, how we draw it, and you better download some maps from Google and practice it accordingly. So let's start the class. So first is, what is geomorphology? In general, we are getting here that geo means earth, morpho means shape, and this logy means study. That means studying the morphological features of the earth. So if you define it, it is defined as the scientific study of surface features of the earth with interpretive description of its landform, their origin and development, and their nature and mechanism involved in the formation of such landforms. Here, the landform which generally we deal with geomorphology are of two types. What are those? One is erosional and other one is depositional. For example, if you take example of a river system. In case of river system, in youth stage, we generally get erosional features. And in case of mature and old stage, we get depositional feature. So these features depend upon the agents which are operating and their capacity, their competency, which involves in case of water, and their erosional behaviors. Their origin and development. It is mainly associated with which stages they are operating. Like in river, if you take example, if you take V-shaped valley, gorges or canyon, these all are dependent upon this erosional feature of the river. Similarly, if you take example of river piracy, river capture, it also happened in all stages, and all stages it happens in different manner. So there is some different development mechanism involved in their formation. Like nature and mechanism. So mechanism are of two types. Like mechanism involves like in some cases like in river case, the mechanism involves like abrasion, attrition. In case of wind, the main process of eroding the sand particles by the deflation process. If you take example of glacier, the main mechanism involves their blocking action. So mechanism also varies from agents to agents. So if you define the geomorphology, it mainly involves these three features: their landform, how they originated, and what kind of mechanism is behind their formation. So in this geomorphology classes we will cover the fluvial geomorphology, arid and semi-arid geomorphology, glacial geomorphology, coastal geomorphology, and karst geomorphology. So let's start the subject with the river or fluvial geomorphology. In this river and river or fluvial geomorphology, we will discuss first about the watershed. Watershed is the very beginning of a river system. So before going or defining the waters, what is watershed, we should learn about some basic terminologies which are associated in the watershed, like source of river, confluence, tributary, distributary, mouth of the river, and some terminologies like watershed, catchment area, river basin. It happens in most of the time we use them interchangeably, but there is some basic difference, that is what is watershed, what is catchment area, and what is a river basin. So what is the source of the river? Source of the river means the beginning or start of a river. Suppose here in this figure, here the source of the river is this area, where the rainfall happens, surface runoff occur. Surface runoff start in small springs, then creeks. They mainly provide as the water to the river. So these area act as source of the river, generally where the river gets its water. Second is tributary. Tributaries are generally streams or small rivers which generally joins to form a larger stream. They also provide the collected surface water to the larger stream. So it gradually increases the water volume of the main river system through which the tributaries are generally joined. Here, these are all tributaries. They join to form a major river that is called master stream. Another term is distributary. Here, distributary is the small rivers that branches out from the main river system. Here in case of tributary, the small rivers are joined to form a large river, but in case of distributaries, the major river bifurcates into smaller river system. Another basic difference between tributary and distributaries are like tributaries are joined with each other, whereas distributaries they bifurcate and they never meet again. Tributaries generally increase the water volume of the main river system, whereas the distributaries decreases the river water volume. That means it happens in the mainly mouth of the river. So distributaries are commonly found on deltas. So if you compare between tributary and distributary, tributary generally develop at youth stages of river. Gradually the tributary goes on increasing. When the river attains mature stage, the tributary number drastically reduces and gradually to old to the mouth stage of the river, where generally a river joins into the sea. There develops distributary system, where the river unable to carry its load, the load dumped on its path, river makes small streams. These small streams provide water into the sea or any larger water bodies. Here if you see in the figure, the distributaries is generally developed at the mouth of the river. Mouth of the river where the river joins with the sea or ocean. Next point is confluence. The point at which the point at which two rivers or streams join. So here you can see the two tributaries they join with each other. This point marks the confluence. Here at this point all the tributaries end up joining. Afterward, there is no tributaries. So this point also marks the point of confluence. So generally, confluence means where the two streams join, whether they are small streams or two large rivers. Their joining point is called confluence. Mouth. Mouth is the point where the river comes to the end. It eventually enters into the sea. So this point marks the mouth of the river. And at this mouth of the river we generally get one of the prominent feature which we know as delta. And if that mouth is open to the sea, that means all kind of wave activity is happening there. The current activity of the sea is strong, then the delta cannot be formed. For example, in case of Narmada and Tapi river. So one of the basic question is determining the bank of the river. So how do you determine? We generally stand facing towards downstream direction. That means here in this figure, suppose this is north direction, this is south direction, and river is moving from north to south. You just stand facing south. Your right hand indicates right bank and your left hand indicates left bank. So now the definition of watershed. So it is a land area that channels rainfall and snow melt, because the water which is moving in a river system is not only fed by the rainwater but also by the snow melt. For example, Ganga river system. In case of monsoon time we get water from rain which fed as surface runoff. In case of summertime we generally get water in Ganga river system by the melting of snow of Himalayan region. So watershed is a land area that channels the rainfall and the snow melt to creeks, then streams and rivers, and eventually to outflow points such as reservoir, bay and the ocean. So overall this area is called watershed, where there are small streams, creeks, rivers funnels all the water to the mouth of the river, and finally from the mouth of the river the water enters into the sea. Commonly the whole area is called watershed. So it is not necessary that all the watershed will directly join into a sea or ocean, because according to the nomenclature or classification, watershed are generally very small features. They cover area around 1000 hectare. So if a river system covers area less than 1000 hectare, then that is called watershed. If it is larger than that, then we will call it as a river basin or a drainage basin system. So the size of the watershed or drainage basin or catchment area is defined on several scales. So one of the basic scale to define the size of the watershed is the hydrologic unit codes. By the hydrologic unit codes, we can define the exact location of the watershed, the particular stream basin which is providing the water into the main river basin, and these hydrologic unit codes are very important in case of like mineral exploration. Suppose we want to sampling the water sampling or geochemical water sampling we want to do, then we will take the help of hydrologic unit codes, because there is a large river system. Suppose we are going to deal with the Gangetic river system. Several watersheds combiningly form the Gangetic river basin. So by taking the help of hydrologic unit code, we can decide the particular area where we want to go to sample the water, to assess the quality of the water, to determine the volume of water entering into the main river system, and some other works like previously we have discussed said about the uh, impedance in sampling like mineralogical sampling, water sampling, and also it is very helpful in hydrologic purpose like uh, deciding the quantity of water entered into the sea, also the water quality over there, and how much water the particular area drains into the main river system, and how much area is covered by that particular watershed. So this is an animation figure which I have already discussed are represented on it. Here rainfall is happening, that is precipitation. These precipitation are falling on the surface, they leading to the formation of surface runoff. These surface runoff start as spring and creeks. They also move as tributaries. Gradually, they join with each other and thus form small watersheds. Gradually, the small watersheds join to form a large watershed. Here, they join with each other, they form small watershed area. This river, these tributaries join to form this watershed. Here, this tributary, this to join to form these tributaries. Again, the water moves to form a large river basin, that is called large river system, which joins here and forms the main river system, and that main river system joins into the sea. Here it is showing the groundwater flow. So there is two basic classifications, like sometimes confusion appears like what is catchment area and what is drainage basin. Most of the time we use them interchangeably, that is the catchment area and drainage basin both are same, but there is some basic difference. Like here rainfall happened, it leads to development of surface runoff. Thus these surface runoff join to form a major river basin. So up to this area, all these surface runoff water they joining to form a large river system. So all these areas which caught up all those water and funnel to this outlet system is called catchment area. Area means we generally dealing with a 2D shape features, because whatever water falling on the surface they are funneling. It is only happening on the surface. But if you take example of drainage basin is three-dimensional. That means what? It deals with the water of surface as well as the water which are supplied from the subsurface. The subsurface water generally percolated down by this precipitation or from surface runoff. At suitable condition, they generally seeps into the surface as springs and supplied water to this river system. So catchment area is two-dimensional, drainage basin is three-dimensional. In case of catchment area, we generally deal with the surface water, whereas in case of drainage basin, we deal with surface water as well as the groundwater. So this catchment area, it refers to all the area of land which rain falls and it is caught to serve a river basin. It is two-dimensional feature. Whereas in case of drainage basin, it is a topographic region which all water drains into a common outlet. It also happens in case of catchment area. Here what happens? It takes into account the infiltrated water which again shifts to the surface as spring and R to surface water flow. It is considered as three-dimensional. So this is the basic difference. Hope you understand. Now water divide. Water divide, it refers to an elevated line or elevated ridge area or land area which separates two river systems or two river basins. Here the watershed A is a river basin, watershed B is another river basin. These two river basins or river systems or two watershed areas are separated by this elevated portion of the land. That elevated portion of land decides the precipitated water should go to which watershed system. Like if the water fall on this region, it will ultimately go to this watershed A region. If it falls on this side, it will go into watershed B. So mainly these two watersheds are separated by an elevated land area that is called water divide. Also the water divide termed as drainage divide. Water divide also called as drainage divide. Then next term is what is river basin. All the areas drained by river and its tributaries is called river basin. For example, we are taking example of Ganga river basin. Here these all areas come under Gangetic river basin because these all areas are covered by or drained by the main river, that is Gangetic river, and all its tributaries. There are many small watersheds within a river basin. Previously I have told you that it is not necessary that a watershed will end up in a sea or ocean. It generally happens that some watersheds, they combinedly form a larger watershed. That larger watershed is called as river basin. Here the Gangetic river system is fed by several small watersheds like Yamuna. This is the Yamuna river and it is fed by several tributaries. Similarly Chambal, here Chambal river. Watershed of Gandak, here it is Gandak river. Here it is only showing only one river, but it is fed by several tributaries. The several tributaries fed water to Gandak river. The Gandak river form a small watershed. That watershed join to some other watersheds and form this large drainage basin of Ganga. So don't be confused about what is watershed, drainage basin, catchment area. Most of the time they will be used interchangeably, but the basic difference are watershed are generally small in size. Then comes catchment area and drainage basin. The basic difference I have already told, that the catchment area covers 2-dimensional and drainage basin is 3-dimensional. Here in case of Ganga river basin, we used the term drainage basin. It can be also used or we can use interchangeably, that is river basin and drainage basin. Here this animated figure shows the combination of smaller watersheds, they join to form a larger watershed. So please try to find out the smaller watershed by drawing on this peak. Here the map shows major river basins of India. These are like Gangetic river basin, Mahanadi river basin, Godavari river basin, Krishna, Kaveri, here Narmada and Tapi. Now, what is hydrologic unit code? I have already told that hydrologic unit code has immense importance in defining the particular watershed. Suppose we now discussed about the Gangetic river basin. Suppose you want to go for sampling of water for hydrologic purpose or some mineral geological purpose for geochemical sampling to Gandak River Basin. You can take example or take help of hydrologic unit code. You can directly go to particular stream which you want to go. Now, the hydrologic unit code is defined or named by these 7-letter words. In these 7-letter word, first 4 are letters. Out of these first 4 letter, 3 letter, first 3 letter here like M, H, D. It mentions the sub-basin, like the name of the river. Here MHD stands for Mahanadi. Last term is L. L marks the sub-basins. Like here the sub-basins are classified as upper, middle and lower. Here L stands for lower. That means here MHD is Mahanadi, L is for lower. Then the last numeric 3 digit like 0, 1, 2, they defines the particular stream number. So here MHD is the river name, L is the lower course, and 0, 1, 2 the particular stream number. Like it may classified as 001, 002, 003 and so on. So 012 is the particular stream number. Here I have given the link of a CGWB site. By going this link, you can visualize all the watershed system of India, and also you can see the data of suppose 012 number stream. You can find out how many areas it has covered. That determines the watershed size. That is, the watershed may covers like 2000 km or 3000 km or 100 km, so on. So please visit this site for better information. So whatever I have explained here, I have mentioned them in these bullet marks. Also you can find this information in this site. Another point is here, like the hydrologic unit code mainly classified as Watershed Atlas of India, and it has a scale of 1:250,000 scale. We generally take this much scale. We can take also some larger scale if you want to determine the particular river system. Some larger scale maps are taken in case of suppose you are going to plan some particular area, like planning of dam is going on, or planning of some river rejuvenation program is required. Then we can take the help of some larger scale map. In generally, the watershed system of India is classified on this scale. So here it is showing the watershed map plotting. So before plotting any watershed, please do practice it, because most of the time in interview they generally give you this map and will ask you to find out the watershed, or it may come in your exam also. So it is important to know. So first, plotting the watershed map, we should know some basic points. Like first point is locate high points on the outlet. Locate high points and the outlet. Here in this point, if you determine the outlet, will go according to the value of contour. Here it is appearing that 4800 is the minimum value of the contour elevation. That means there must be an outlet at this 4800 value. So at this red mark area, we find out that it is the outlet. Now we should look at the high points. Here the high points are like 1 point, it is here like 75151. Another one is here. Next one is here. Next one is here 7025. These all are the high points which are easily located. Now we should draw the ridge line because it is the elevated land area. If you go to the right side, you are getting that the contour elevation is decreasing. If you going to the left, you are also getting that the contour elevation is decreasing. That means it is a ridge area which separates two different watershed systems. So join it, and while joining, you should join cutting the contour lines perpendicularly. You should go like this by joining all the contours perpendicularly. Yes, we joined it. Now it is joined to 7025. Then plot also there is no value, but we can extrapolate it in this direction. So this area marks the ridge line. Ridge line we also call it as, when we will do the complete plotting, we also can term it as water divide or drainage divide. Then we will go down the valley to plot the watershed. Now if you go down, we will find the areas first. Imagine the areas where it can go to join that particular outlet system. Here if you go here in this direction, here you join it, then we'll go like this. On other side if you go, you can go like from this outlet I am drawing. You also can draw it from the ridge line, but the main important thing is here, just find out the proper way which you can join the outlet with the main ridge system. Now it is joined. So this area marks the watershed. So there are a lot of maps available in Google. You can download them and practice this map. If you do some practice, then it will be easier to locate the ridge line, the outlet point, and the suitable way to join them. So this is the end of the slide. What you studied in it? We just studied the terminologies like what is watershed, what is catchment area, what is drainage basin, and what is river basin. We also studied the hydrologic unit code, how you define a hydrologic system, and the plotting of the watershed map. So on detail about the river we will learn about in coming classes. So in this pandemic time, please be safe and keep others safe. So thank you for your patience hearing.